Today we are reading the first part of Volcanoes by Brett Kelly on pages 12, 13, 14, and 15. At first glance, Naples appears to be like any other bustling European city, tucked along the west coast of Italy. Naples has a picturesque bay to the west and a majestic mountain rising to the east. Look closer, however, and you will see that there is a nearby mountain that is in fact Mount Vesuvius, a very large active volcano. When it erupted in 79 CE, CE stands for current era, meaning we're in 2020 current era. This is 79 CE. So when it erupted in 79 CE, it rained poisonous gases, rock, ash, and scalding hot lava down the surrounding cities and their inhabitants. Inhabitants are people who live in a certain place. What causes violent volcano eruptions like this? The answer lies deep within the earth. So here's Naples. Italy kind of looks like a boot, as you can see, the shape there. And Naples is an island off of it, and Mount Vesuvius is right on there. Italy is home to Europe's only active volcano. Mount Vesuvius most recently erupted in 1944. And there is Mount Vesuvius, as you can see. I actually went to Italy 8 years ago, and I actually saw Mount Vesuvius in person. So here is a picture of me at Mount Vesuvius 8 years ago. Looks just like the picture. I don't think I realized that it was still an active volcano at the time. I think I would have been a little bit more nervous. It hasn't erupted since 1944, but it could erupt at any time technically. It looks like just like a hill, but right next to the mountain is the city of Pompeii, which we will be reading about a lot in the next couple days. And the city of Pompeii is really interesting. It is right next to Mount Vesuvius, and it is the city that was completely damaged by the eruption of Mount Vesuvius. Here is my sister and I actually at the ruins of Pompeii, right next to Mount Vesuvius. As you can see, there's still some things standing, but the city is definitely was demolished by this volcano. We'll be reading a lot more about it today, and I'll be sharing some of my experiences when I was there visiting Pompeii. So let's learn more about why volcanoes happen in the first place. So up here we can see that we have already learned about the different layers of our Earth. We have our inner core, our outer core, our lower mantle, our upper mantle, and our crust. Remember, the crust is like the plate is like a cutie when you pull the orange peel off, that is what covers up the orange, right? Well, the orange peel is like our crust, which is made up of tectonic plates. Earth's layers. The surface of Earth is always changing because of its structure. Earth is made up of 4 different layers: the crust, the mantle, the outer core, and the inner core. The crust, or solid outer shell, is the thinnest of the 4 layers, and it is the one we live on. The crust is formed from giant slabs or plates of rock. These plates fit together like pieces of a jigsaw puzzle. Together they float on another layer called the mantle. So this is what I was just describing of an orange peel. When you peel off an orange, it comes off in chunks, but you could put it back together to make the shape of an orange. That's exactly what we're standing on right now. Our plates of thin rock that goes right on top of lava and float on there like a surfboard on top of our mantle. The mantle is the layer that surrounds Earth's center or core. It is about 2,900 kilometers, 1,800 miles deep. It's very deep. The mantle is divided into 2 sections. The upper mantle is composed of cold, dense rock. The lower mantle is made up of partially molten rock that flows. This is the area that causes the shifting of tectonic plates just below Earth's surface, creating volcanoes and earthquakes. So these are the layers of our Earth cause both earthquakes and volcanoes. The next layer is Earth's outer core, which is made up of very hot liquid molten lava. The outer core is about 4,900 kilometers, 3,000 miles beneath the surface of the Earth. The inner core is even deeper. It is a solid ball made of metals. The heat and pressure inside Earth are so great that solid rock is constantly melting and forming liquid magma. Because the liquid magma is lighter than solid rock, the magma rises and the solid rock sinks. Some magma cools as it rises, becoming solid rock and sinking again. Other magma remains liquid and collects in underground chambers. When the heat and pressure build in these chambers, the magma is pushed through the cracks in Earth's surface. The result is a volcanic eruption. Magma that has erupted through cracks in Earth's surface, or crust, is called lava. So here's a diagram. It shows lava, ash, gas, and steam erupting. The cone shape of the volcano is the result of past eruptions that have pushed rock up into this form. Hot melted rock called magma rises from the magma chamber, making tubes called pipes along the way. Some magma goes straight up the volcano and out the top. Some magma escapes through the side vents of the volcano. Plate boundaries. According to the U.S. Geological Survey, USGS, there are 7 major plates on Earth, subdivided into smaller plates. As these plates float, they slowly slide past each other, spread apart, or collide. When 2 plates meet, it is called a plate boundary. Most volcanoes occur at plate boundaries. Vesuvius, for example, is part of a line of volcanoes that formed over the boundary between the African and Eurasian plates. Some volcanoes, however, occur at the interior of plates. These spots are thought to be especially hot regions in Earth's mantle that spew magma onto Earth's surface. These areas are called hotspots. Pico do Fogo, for example, sits on the African plate and is therefore considered a hotspot volcano. Hotspots can create entire chains of islands, like those forming the U.S. state of Hawaii. So our state of Hawaii is actually formed by hotspots that make islands. So as you can see, this is an informational science text that teaches us what volcanoes are and how they happen. This is just part 1 of this reading. Part 2 will be coming next. Thank you for listening, and I look forward to learning more about volcanoes with you all.